Company's #1 Google Slides live stream, coming at you now directly from Rockingham Township, Vermont, of all places. And I'm sorry I haven't been on here for a while, but you know, I've just been cursed with slow internet for the past several weeks. It seems like God doesn't want me to talk about all of his shitty miracles. But guess what I found to talk about instead, though? When I was reading this book, Theophrastus Peri Meteorologias, though in fact it survives not in the original Greek, but in an Arabic text which is translated from a Syriac text, both of which we have. And I was reading this for some reason or another, and I came across this interesting passage that seemed, a little bit topical. I was reading I came across this passage that talks about lightning bolts, discusses and explains lightning bolts. The thing about lightning bolts is that they're made of both air and fire, or perhaps, the other option, they're made of both fire and air. And that's how come they move through the air, but can also set things on fire. That's Theophrastus's claim. And you know, that's kind of relevant because we've all had a rough summer of lightning bolts setting things on fire all around us. Well, maybe that'll all make a bit more sense to us from the point of view of ancient meteorology. That's the hope anyway. The ancient meteorology is what I'm going to talk about today, next little while. Now, speaking of meteorology, maybe the name seems weird to you. It's the thing that people do on TV, right? When they're predicting the weather. Not those handsome folks who are actually standing in front of the screens, but actually nerds in labs in various places who produce those maps. Meteorology. You know, it seems like, right, it should mean study of meteors. But nowadays, it's actually just about weather. And that conflation, meteors and weather, gets to the heart of the weirdness of this Greek science that's not really comparable to any kind of a science that we have nowadays. Meteoros in Greek means off the ground, up in the sky, and meteorologia in Greek is the study of stuff that's up there, stuff that's above you, which includes the weather, but for the Greeks, it also includes meteors. The really interesting thing is kind of what it doesn't include, which is what we'll get to in a minute. What does up there mean? What's meteoros? That's kind of the same thing for Greeks as asking where the sky stops, which is the domain of the meteoros, from the Greek point of view, is just kind of this area above the earth, but below space, kind of. The terminology is not quite right. Thinking about it from kind of the earthbound perspective, right? We look up at the sky. What we're seeing is an optical illusion. It's not anything real. It's just the effect of a solid surface produced by Rayleigh scattering in the atmosphere, the water vapor, various gaseous diffraction of the sun's light. So it looks like this kind of solid object, but it's not, as this diagram kind of suggests. Where the sky stops remains a good question today. Well, is the International Space Station in space, or is it in the sky? On the one hand, it is called the International Space Station, but on the other hand, roughly the same altitude as like the Aurora Borealis, which I think most of us would identify as a sky phenomenon. It's within the Earth's atmosphere. There are detectable levels of gas. But the atmosphere up there is certainly very different than the atmosphere that we live in. It's not breathable. The gases start to be diffraction separated. It's a different kind of atmosphere. So this question of where you draw the edge of the sky is actually, from a scientific perspective, a really vexed one. So when I kind of draw the line arbitrarily, maybe you could do something like the Kármán line as it's illustrated on this chart. Basically a line above which it is impossible to fly in an aircraft because the air is too thin to generate lift. So above that point, you're in some kind of a space shuttle or rocket or whatever. Otherwise, you're not going to be above the ground. But that's an arbitrary designation for a border for the sky. The Greeks, before and after Aristotle, in the philosophical tradition, say, well, the sky stops at the moon's orbit, at the bottom of the moon's orbit. And that's a clear and a well-defined boundary, and it's not as arbitrary as something like the Kármán line or any of the other various borders of the sky that modern scientists draw. So that's an advantage. On the other hand, the moon's like hundreds of thousands of miles away from the Earth, so that produces like quite a big sky, maybe bigger sky than we'd want. And the Greeks are aware that there's quite a distance there. But for them, the moon does mark this kind of important boundary. It marks the boundary between what's changeable and what's not. Because the moon, unlike any of the other celestial bodies, supposing you don't have a telescope to look at them, the moon is changeable. The moon has phases. The Sun, Venus, Mars do not have phases from the perspective of a non-optically enhanced terrestrial observer. So it's this boundary between what's changeable and what's not. And everything on the Earth is very changeable, of course. So the moon sort of represents this boundary that surrounds a world and marks off a world that's like the one that we live in, a world governed by the laws of physics, for instance. The moon is where the chaos begins as you move inward from there. Everything just goes crazy. There's a different explanatory logic that applies above the moon and below the moon. Two different explanatory logics. You got outside the moon's orbit, a very orderly circular movement of planetary bodies within spheres. A movement that, for a lot of ancient observers, reduces to a kind of pure mathematics. A movement that's governed by mathematical rules. And a movement that's governed explicitly by the will of a prime mover. Whether you think that's kind of a non-anthropomorphic Aristotelian prime mover, or prime intelligence, or whether you think that's some kind of a god, the celestial spheres where the planets and the stars are under their control, and therefore quite orderly. By contrast, below the moon's orbit, you're in the domain of Meteorology, this kind of pointless, merely physically caused churn of the elements. Whereas outside the moon's orbit, you've got a teleological causation on the part of a directing intelligence. Within the moon's orbit, it's just all material causes, things bumping into one another, physics and chaos. Which, fine if you want to look at it that way. It's not the craziest idea to have. But also, like, meteors happen beneath the moon. And comets happen beneath the moon. That's because those are changeable things, right? So they have to happen within the domain of stuff that's changeable. So that's why meteors and comets also fall within the domain of meteorology. The study of what's up there, but also the study of things that are changeable and things that are therefore assumed to be within the orbit of the moon. So the controlling kind of explanation for these meteorological phenomena, the thing that ties them all together is that they all come from various sort of exhalations of the Earth, vapors that arise from the Earth, and that seeking their natural location in the air or fire, which are closest to the moon, move away from the Earth and rise. So they're kind of like Earth farts. When they bump up against the orbit of the moon, they kind of get heated up by the movement of the moon sphere, and that friction creates the appearance of a comet or a meteor. So it's an Earth fart that's been lit on fire, basically. And in this context, we shouldn't forget either about earthquake weather, because earthquakes, despite not really being above us, not really being meteoros in the etymological sense, are also considered part of this explanatory sphere. You know, you get this problem where sometimes the earth farts build up underground, and you get a lot of pressure, and then when they break out all at once, there's this kind of an earthquake. It's a very loud earth fart. Let's hope that we don't end up having one of those on top of all the other stuff that's going on right now, I guess. So this sphere of ta meteora, the things governed by the laws of physics and material causation, goes from underground, the center of the Earth basically, up to the edge of the moon for Greek philosophers. So it's kind of coherent object of study, and it's got coherent explanatory theories behind it, a bit different than the way we would now divide the world up, but it has a logic of its own, is I guess what I'm trying to say. It has a logic of its own, and it's useful in all kinds of ways. From a stylistic point of view, meteorology is really good for sublimity, talking about big stuff. So epic poets, particularly Roman epic poets, because they're writing with an eye back towards Greek science often, talk about the weather a lot. And they invoke theories of causation that come from a lot of this earlier Greek science in their poetry. That stuff's all over the Aeneid if you're looking for it, for instance. A way of creating sublimity and showing that there's kind of a cosmic scale, not quite cosmic, but at least out to the edge of the moon. There's quite a vast scale to the stuff that's going on in the epic, even though it's just happening to human beings like you or me. Some philosophers even take this a little bit further and replace the gods of epic with meteorology. It's a way of getting away from the kind of divine causation that a Homer will invoke, say, while still maintaining a sort of impressive causal apparatus that seems to explain things like lightning bolts, for instance, right? You want to offer an explanation for lightning bolts that is adequate to the size of the phenomenon, but doesn't require talking about Zeus. That's important. So Epicurus is really big on meteorology too. Meteorology is for Epicurus a kind of a theology, a mode of explanation that makes the popular conception of the gods just unnecessary. Why do you need Zeus if you can explain lightning bolts via earth farts? And looking for kind of explanations like that becomes a bit of a sport also. A sort of philosopher fight club, a dinner over dinner conversation, explaining weather stuff according to the rules of meteorological explanations is something that philosophers and poets and encyclopedists like to do in their books, and also to the extent that we have records of these conversations when they're talking to one another. Implicitly, they're in competition with one another and also with the various other amateur meteorologists who came before. If you can explain more stuff than earlier amateur meteorologists did, then your theory is superior. That's how you win this horrible weather slap fight. Well, but where does that get you? Can you actually develop a sort of a predictive apparatus, or at least an understanding of the way that ta meteora, all the stuff between the moon and the center of the Earth, works? Can you develop an understanding of that based on these meteorological principles? Some will say, well, it's all a bit beyond us. We can generate a lot of explanations, but not necessarily the right ones. And interestingly, that's the position of Epicurus. For all that he relies on meteorology to undermine the authority of Zeus, he also says these phenomena can be explained in many ways. And it doesn't matter if you get the explanation exactly right. All that matters is that you have at least one explanation available to you. From a slightly different point of view, early Christian authors will look at this meteorological tradition and say, well, maybe there are limitations to human reason that prevent us from understanding all of these phenomena in a full and complete way. The non-comprehensibility of meteorological phenomena doesn't show that they're all directly caused by God. God isn't zapping people with lightning bolts all willy-nilly. But it does show that God controls forms of causation that we don't understand. So it demonstrates the gap between divine knowledge, divine omniscience, and what human beings are capable of. And to follow that Christian critique further, people like Augustine especially will say, well, maybe there's no point. Why bother looking above and below and investigating all that stuff, the spirits of the air and the fart-filled caverns under the earth? Why bother looking at that stuff when you should be looking into your own soul and critically evaluating that soul, rather than being curious about all this other nonsense? Well, that's something that Augustine's really into, and a lot of other early Christian and medieval Christian authors come down pretty hard on. But one Jesus H. Socrates had, of course, said it already, and perhaps even better, said that you should focus on ethics, not the weather. This is a point that Plato's Socrates makes over and over again. I'm not interested in the heavens and the earth. I don't care about all this meteorology. I'm interested in ethics, in psychology, in understanding the human being. Like I said, that's Plato's Socrates. The real one may have been more of a weatherman. The illustration that I used for Meteora at the outset is from an early modern edition of one of Aristophanes' plays called The Clouds, one of the first and funniest meteorological treatises. But it's a play that features Socrates as a character. And we first meet him in the play, sort of hanging in a basket above the ground. And somebody asks him, why are you hanging up in a basket up there? And he says, well, I want to get closer to the air so I can understand Meteora better. I'm walking on air so that I can get what's going on up in the heavens better. The basket is a kind of a joke version of a telescope, this kind of instrument that can help you understand what's going on in the sky more effectively. Because, of course, given the technological apparatus of the Greeks, there isn't a lot of instrumentation they can use to figure that stuff out. So the point of Aristophanes, or the point of the joke, is that interest in meteorology is impractical. And that's also what Plato has Socrates say over and over again in the dialogues. But, well, there are some practical applications for meteorology in the ancient worlds. Of course, predicting the weather, right, would be a practical application of meteorology. This is almost a separate field of meteorological speculation in the ancient world. It doesn't involve Doppler radar, but it does involve astrology. The theory being that although the unchanging heavens are separate from this chaotic sublunar world where meteorology holds, they do exert an influence on the earth and the elements. And that influence is, in certain ways, regular and predictable. So if you watch what the stars are doing, you can know what the weather's going to be. There's a huge accumulated knowledge of this in inscriptions, in poems, in technical literature, how to predict the weather on the basis of the stars. And, in a sense, this is pretty reasonable because, the star positions do change on an annual basis regularly. And they do correlate with seasonal change. Um, when it's Scorpio season, that is when the sun rises in Scorpio, it's cold. In Leo season, when the sun rises in the constellation Leo, it's hot, because Scorpio is where the sun rises in the winter, and Leo is where the sun rises in the summer, at least in the northern hemisphere, which is where all of these ancient observers are situated. So, there is a utility, there's a sense in which you can predict the weather on the basis of astronomical observation. You can do meteorological prediction this way. But in another sense, it's not quite what we mean by weather prediction. It's more like climatology. It's more like climate. The information you get by paying attention to the stars is information about regular recurring events, not sort of day-to-day events. You don't need a weatherman to know which way the wind blows. Well, you do, but you don't need a weatherman to let you know that it's going to be hot in summer, cold in winter. So the information that astrology gives you is kind of climate. It's the average of weather over a multi-year period. Modern meteorology is looking for something quite different. Modern meteorology is looking for day-to-day variation. It's looking for the stuff that you can't predict just by knowing that it's summer or by knowing that it's winter. And as such, it kind of brings its own object into being. It creates weather as something predictable, as something that's separate from climate. Something that you can aim to predict using different means than you would use to predict the climate. Things like Doppler radar and what have you. Technology and technique allow us to see the weather as something different than climate. We can make predictions both about the climate from year to year and about the weather more narrowly from day to day. And that second thing is something that ancient meteorologists were, for the most part, not interested in, aside from a few your ground rules like red sky in morning, sailor take warning, that sort of thing. The separation of weather from climate and the ability to predict weather are kind of modern inventions. And that's important in another way, too, for modernity, because the background assumption in ancient meteorology is that climate is stable. Ancient predictive meteorology assumes that the climate's going to be stable over long terms, over centuries, millennia, etc. And it really has to be, if the climate's going to be predictable. If past observations will tell you about future climate, then the climate has to be stable. Well, now that we can predict weather independent of climate, and that we have means of making these predictions independent of like the annual rotation of the zodiac, we don't need to assume that climate's going to be stable for our predictive apparatus to have any good, to do any good. And that means that we can also start thinking about the climate changing, which is a lucky thing to be able to think about right now, especially as the climate is over most of the globe, but in some areas especially, becoming extra spicy. Now, for something completely different. There is a really interesting coda to the meteorological treatise that got me going on this, Theophrastus's Meteorology. There's an interesting coda to that text, and it is only present in one of the Arabic manuscript traditions. There's what's called a stemma on the slide here. A stemma is an indication of the relationships between the various manuscripts that there are of an ancient text. We can't go further back than the Syriac translation here. The Greek original has been lost. There are various extracts from the Syriac translation that show up in various places. That gets translated into Arabic a couple of times, and only in the texts descending from one of the Arabic translations. That's the complete Arabic translation by Ibn al-Khamar in the 10th century. It's actually a Christian translating in Arabic. as many of the earliest Arabic translators were, Christians with knowledge of Syriac translating into Arabic. Um, so only in that set of manuscripts do we encounter this coda. You'll see when we talk about what the coda contains why some Christian and Islamic writers might have wanted to drop it, might have wanted to cut it out. It would be somewhat surprising, too, if Ibn al-Khamr wrote this, the coda himself, given that he himself is, as I said, a Christian author. But it is a coda that explicitly contradicts the Quran down to its vocabulary, because it talks about lightning bolts again, and it uses the word zalqa, which in the Quran is definitely from Allah, definitely created by God. Well, if you think, this is what the coda says, if you think that God sends lightning bolts down, you're a sucker. Because, among other things, lightning bolts zap the good and the bad equally. And, they tend to hit high places for no good reason, and they zap animals. What's the point of that? Why would God want to zap animals? So, you can't say about lightning bolts and things like lightning bolts, storms, etc. You can't say about these things that they come from God. All you can say is that it happens without any order. It happens without order or justice, and that is where I leave off this discussion of ancient meteorology. So, assuming that my internet maintains its speed, I will see you back here next time, same time next week, same place next week. Everyone have a good weekend. Stay safe. Stay not on fire.